Hello, Physics Nation. My name is Nate Larmond. I'd like to do a Khan Academy problem um, based on a vertically launched projectile. We are juggling a beanbag, and we launch the beanbag with a vertical velocity of 1 meter per second. How long does it take for the beanbag to reach its maximum height? Round the answer to two significant figures. So this is similar to the problems we did in week 3 because we're given some kinematics data, and we got to choose an equation, except now they're actually asking us to find the numerical answer. It's a pretty simple question. The hard part is they only tell you one piece of given information, the launch velocity. It's going up initially, vertically at 1 meter per second. Pardon the scrolling. So it's about choosing the right equation, like I said. So I just wrote all 5. Here's average velocity equals displacement over time. Here's average velocity equals initial plus final velocity divided by 2. Here's the definition of acceleration. Final velocity minus initial velocity divided by time. I call this the fancy one with time. Its displacement equals 1/2 at squared plus VIT, and I call this one the fancy one without time. VF squared, that is final velocity squared minus initial velocity squared, equals 2 times the acceleration multiplied by the displacement. I tried to make everything y, like acceleration in the y direction, displacement in the y direction, and yeah, there are 2 secret assumptions. There is no velocity at the apex. Just for one moment in time, I believe we called it the Michael Jordan effect, the projectile freezes. And whenever you see falls, dropped, thrown, shot, jumps, you can assume the acceleration to be negative 9.8 meters per second per second. That is, things change their vertical motion by 9.8 meters per second every second if gravity is the only significant force acting on them. So if you know the final velocity and you know the acceleration and you know the initial velocity and you're looking for time, well, we're going to grab equation 3, the definition of acceleration. Multiply both sides by t, divide both sides by acceleration, and so you get the elapsed time equals the final velocity minus the initial velocity divided by acceleration. We have a really weak launch velocity of 1 meter per second, a very severe acceleration of 1g, or 10 meters per second squared. 1 divided by 10 is obviously a tenth of a second. So it takes a tenth of a second to go up and another tenth of a second to go down. That means this thing is coming back to your hands in 2/10 of a second. You could not juggle anything that fast. So Khan dropped the ball. Get it with this given information. Anyway, thanks for watching. See you in the next video.